Hello, everyone. I am Reza from Group 119. So this is a brief explanation about our project, Deep Learning-Based Facial Emotion Recognition on the final project of Neural Networks course, and I'm happy to be here. So starting with a little brief introduction on our project. So in this project, we aim to develop an intelligent framework for facial emotion recognition using facial pictures. And after this project, we plan to enhance the human-computer interaction and enhance customer service security and many other applications which uh, are related to facial emotion recognition using pictures and videos. So I'll start with a brief explanation about our data and input and output. So the data set that we're using is FER 2013. So we are dealing with grayscale images, 48 by 48, and we've got 7 classes of angry, disgust, fear, happy, neutral, sad, and surprise. On the right-hand side, we can see some visualization of these pictures and the data set. So that we are dealing with input of 148 by 48, one channel, it's grayscale, and 48 by 48. And in the end, we're going to have 7 neurons, 7 output neurons, indicating to which class a picture may corresponds to. So I have to say that we had class imbalance problem. So we solved this problem, and we tried to solve this problem using adding samples by data augmentation. Before I dive into our method and our own proposed work, I will provide a brief explanation about our baseline models that we investigated. So technically, we investigated 2 baseline models. The first one was random forest, and the next one is MLP. So I'll start with a brief explanation about random forest. So random forest is an ensemble learning method in which multiple decision trees are developed based on the picture which we have provided here. As we can see, each decision tree operates based on features and decide which branch it should go to, and this thing continues until it reaches one of the labels. And in random forest, multiple decision trees are trained. Each one of them are giving us an output, and after all of the outputs, there would be a majority vote and averaging, and we will take the final output of all of these decision trees as the final output of the model. And NLP is it's just a simple fully connected layers cascaded to each other, as we can see that the architecture can be seen in this picture. But one more thing that I should mention here is that as we are using random forest and NLP for the baseline model, we are no longer able to feed the 148 by 48 pictures. So what we do is that we flatten the data to 2304. So we flatten our data, so we will no longer have a matrix but a vector. So this is the performance of the random forest. I will dive into more details later when it comes to comparing to our work. Same thing goes for MLP here. As you can see, we are not able to, these models, the baseline models are not able to get good performance because they're a very simple model and they cannot generalize to a complex data set with like 48 by 48 matrices. So now I'll dive into the details of our work. So what we proposed is a CNN architecture cascaded of multiple convolution layers and one fully connected layers. So our model consists of 3 convolutional layers cascaded to each other. Each convolutional layer consists of multiple feature maps, batch normalization, followed by some activation layers. Again, the same thing goes with convolutional layers, again, batch normalization and multiple dropout layers, which were all covered in the course. So each convolution layer, as you can see here, more details are available in the pictures that we have provided. Each convolution layer consists of multiple convolution layers, feature maps, activation layers, batch normalization, and dropouts. And these convolution layers are, the data that we have, one channel, the single channel 48 by 48 picture that we have is fed to the first convolution layer. And once it reaches the fully connected layer, everything we have will be flattened, as we can see in the description of the fully connected layer. And then we've got multiple layers of fully connected layers. And in the end, we're going to have 7 output neurons indicating to which class this picture of ours corresponds to. And I have to say that this architecture and other learning parameters like the optimizer, the weights of the cross entropy, and other learning parameters and the architecture were just acquired based on simple grid search hyperparameter optimization. So after testing multiple architectures and multiple settings of training, we reached this final architecture for the final model. So now we can see that as we had seen on the baseline models, we were not able to get good accuracy, but here we are able to increase the performance by around 20% on the test accuracy. On the left-hand side, we can see the test accuracy, which we have around 65% test accuracy. We can see other evaluation metrics like precision, recall, F1 score, and other class-wise. And on the right-hand side, we can see the confusion matrix, which, as we had observed before for the baseline model, the confusion matrix was not that much good because the models are so simple and they couldn't generalize to complex data. So in this slide, I'm going to provide more comparison analysis. So on the left-hand side, we started the random forest, in the middle is the MLP, and on the right-hand side is our proposed work. So as we can see, the confusion matrix of our work has enhanced way better because it was optimized and the architecture can generalize to a complex data set. And we can see that we were able to get around 20% better test accuracy in comparison to the baseline. That was all about our project. So in terms of regarding prior work and reference, our group had the experience of working on MNIST classification and CFAR10 classification problems, and also developing intelligent vision frameworks for autonomous vehicles. And the references, reference one indicates where you can find the data set that we used, and reference two and three are some recent works which have been done in this area that we accomplished the project. Thank you very much for watching, and I hope you have a good day. Thank you.